every basis, we're given a space, given a space, R3 or Rn, or some other column space of a matrix, or the null space of a matrix, or some other vector space. Then the great fact is that every basis for the space has the same number of vectors. If one basis has 6 vectors, then every other basis has 6 vectors. So that number 6 is telling me, like it's telling me how big is the space. It's telling me how many vectors do I have to have a basis. And of course, we're seeing it this way. That number 6, if we had 7 vectors, then we've got too many. If we have 5 vectors, we haven't got enough. 6 is sort of like just right for whatever space that is. And what do we call that number? That number is, now I'm ready for the last definition today, it's the dimension of that space. So every basis for a space has the same number of vectors in it, not the same vectors, all sorts of bases, but the same number of vectors is always the same, and that number is the dimension. This is definition now. This number is the dimension of the space. Okay. Okay.